y of 1. So the first thing that you have to do is you have to change this into standard form, y prime plus px y equals to qx. Because only then you can talk about the multiplier, which is e to the integral of px dx, right? So to make this into this form, you better just like this. You better divide by x squared. So let's divide by x squared. This becomes y prime plus 1 over x squared. Y equals to 1 over x cubed. Okay? And then we can see what p of x is. What's p of x now? This one. 1 over x squared. That's px, right? So we can calculate the multiplier. Multiplier is e to the integral of 1 over x squared dx, which is e to the negative 1 over x. We just you can find out the integral of this by rewriting this as x to the negative 2, or you can just memorize this, which is better. Okay. When you calculate this, don't put plus c because you just need one multiplier. There are many different multipliers. That's I mean, you could have plus 1 or plus 2 or anything, but we just need one. So just this. After figuring out that this is the multiplier, which one do you multiply this to? The first one or the standard form? Huh? It has to be this one or that one. Which one? Where do you multiply this? The second one, this one, the standard form. Okay, you have to change to standard form, and this has to be multiplied to standard form. Okay, so let's multiply e to the negative 1 over x y prime plus 1 over x squared e to the negative 1 over x y equal to 1 over x cubed e to the negative 1 x. And the reason for doing so is because then this side becomes a product rule. So this is same as e to 1 over x y prime. The right side I just copied it down, but you can check that if you apply the product rule to this product, then one of them will produce this one while the other will produce this one. It's nice to check it because then you know whether you're on the right track or not. Okay. Yeah. So what do I get if I actually differentiate it? If I differentiate e to the negative 1 over x, you need to use the chain rule, right? The chain rule says differentiate it as if negative 1 over x is just x, e to the x, so e to the x differentiates to e to the x. But then this thing should be regarded as an inside function, so that has to be pulled outside, and you have to differentiate it, which is e to the negative 1 over x times, this is 1 over x squared. So 1 over x differentiates to 1 over x squared with a minus sign. And therefore, if you differentiate this one, it will create exactly this one times y. If you differentiate y, you're going to get exactly this one. So you see that if you apply the product rule to this, you will create both of them, okay, because of this single calculation. But anyways, so that was just a quick check that we were on the right track. This is not completely necessary. So let's continue from here. So what do? We have to integrate both sides. So let's see. So let's integrate. Integration of e to the negative 1 over x y prime dx equals to integration of 1 over x cubed e to the negative 1 over x dx. The left side is easy. If you differentiate something and then integrate, they're like opposite operations, so they cancel. So the left side is just this. That's easy. The right side is the challenging one, and in fact, I was surprised to see that nobody in this class were able to do this integration. Okay. All right, first of all, what's the integral of 1 over x, negative 1 over x dx? Do you know this?
Over e negative 1x squared, 1 over x.
So give me an answer. So you think, what is this?
E raised to the negative 1, 1 over x squared.
You think this is the antiderivative?
Yeah. Okay.
So let's check if that's true.
No.
No,
Yeah,
it's not?
yeah.
Okay, so you give up. All right. Anybody else? Anybody else? Does anyone know the integral of this function?
E to the negative e to the.
It's quite complicated, so let me show you. U equals to negative 1 over x. You say this. Then du is 1 over x squared dx, because if you differentiate negative 1 over x, it's 1 over x squared. Therefore, this is like u squared dx. Right? Because if you square both sides, it's u squared is 1 over x squared. And therefore, you can rewrite this as integral of e to the u times 1 over x squared. Sorry. If you solve this for dx, you get dx equals to du over u squared. So it's 1 over u squared du. And that's when you realize that you can't do this integral, because if you have e to the x or sine x or cosine x over a fraction, that's one of the integrals where the antiderivative does not exist.
That's also not including the 1 over x cubed, right?
It's not including this.
All right.
Yeah. So this cannot be done.
Yeah.
Right. And the reason this integral is hard, because a lot of you tried to think of this as a product rule, thinking that you could find the antiderivative of this, but as I just said, the antiderivative of this cannot be written in a closed form. Okay? So that's exactly not what you want to do. Instead, what you have to do is to set u equals to negative 1 over x for this one, and do the transformation. So it's again the same story. If you do this, then dx is equal to 1 over u squared d. No, actually, let's do it like this. Dx is 1 over x squared. Du is 1 over x squared dx. From there, let's just say dx is x squared times du. For this, I like this because 1 over x cubed and x squared can cancel each other, right? So let's do that. 1 over x cubed e to the u, and dx is now replaced by x squared du. And then you have x squared and x cubed canceling to give you 1 over x e to the u du. And then, what is 1 over x?
A constant?
No.
No.
X and u are related, so when you change u, x does change, so it's not a constant. That's very important. When you do an integration by some variable, you have to ask yourself, does this change when you change u? And right now it is true, because if you change u, the value of x should change.
It's
Right?
negative u.
It's negative u. See, this one says that 1 over x is equal to negative u, and therefore this is negative u e to the u du, or negative integral of u du. And only then you can use the integration by parts. So d integral plus minus, so it's u1, 0, e to the u, e to the u, e to the u, plus minus plus. So that's negative of u times e to the u minus e to the u plus c, which is u, that's 1 over x squared e to the negative u, no, sorry, 1 over x e to the negative 1 over x, and that's plus e to the negative 1 over x plus c. And then finally, when you divide both sides by e to the negative x, your answer, final answer is y is equal to 1 over x plus 1 plus c times e to the 1 over x. So that's the final answer.